Hi students, today we are moving on to the next topic, that is solution of a PDE. How to find out the solution of a partial differential equation. Okay, now the first method is by direct integration. When we use this direct integration, that is direct integration is used when we are given only one partial derivative. If we are given only one partial derivative, then we use direct integration for finding the solution of the PDE. Also, by taking integration along the direction of one variable, we consider the all other variables as a constant. That is, in direct integration, when we integrate in the direction of one variable, we have to keep all the other variables as a constant. That is the main thing you have to keep in mind. Okay, now I am going to a problem. First problem, dou square z by solve, dou square z by dou x, dou y is equal to sin x. Here, first we have to find out dou z by dou x or dou z by dou y, because this is a second order equation. That is, dou square z by dou x dou y is a second order differential equation. So we have to find out, we have to integrate this two times. Then only we reach z, we get z, the value of z. So we have to integrate this with respect to x and with respect to y. That is, two times integration is needed. So first I am going to integrate in the direction of x-axis, that is integrating with respect to x. Look at this. This is equation number 1. Integrating with respect to x. While integrating with respect to x, this dou square z by dou x dou y becomes dou z by dou y. That is, we are integrating with respect to x, then the order becomes order reduced to first order. That is order, this is second order. First when integrate, the order becomes 1. So this becomes dou z by dou y. I am integrating with respect to x. So here dou z by dou y, equation 1 becomes dou z by dou y is equal to integral of sin x with respect to x. That is integral sin x dx plus a constant of integration. Instead of adding the constant of integration c, here we are adding an arbitrary function. We have to add an arbitrary function of variable which we kept as a constant. Here, what is a constant? We are integrating with respect to x. So y is a constant. So we have to add a function in y here as an arbitrary function, not arbitrary constant. We have to add arbitrary function, that is f of y. Here, what is integral of sin x? Integral of sin x is minus cos x. Okay, minus cos x plus f of y. This is equation number 2. This is equation number 2. Now I am going to integrate this equation with respect to y. Integrating equation 2 with respect to y. Okay. Therefore, equation 2 becomes, this dou z by dou y becomes z. Z is equal to integral of minus cos x with respect to y. That is, minus is taken outside, integral cos x dy plus integral f of y dy. Okay. Now integral cos x dy. How we integrate this cos x with respect to y? While integrating with respect to y, all the other variables are kept as a constant. So this cos x is a constant here. So cos x is a constant, we have to integrate integral dy. What is integral dy? Integral dy is y. So this becomes minus y cos x. Okay, minus y cos x plus, now integral fy dy. What is the integral of fy with respect to y? This is a function in y. We don't know what is this function. This is a function in y. That only we know. F of y is a function in y. We have to integrate this function with respect to y. While integrating a function in y with respect to y, what we get? We get another function in y. So I am writing integral fy dy as capital F of y. Okay, whatever the function may be, let it be fy, capital F of y, plus a constant. Now I am going to add an arbitrary function there. That function must be in which variable? In x, because x is a constant here. Here x is the constant, so I am going to write here gx. Okay, so the answer is, solution is z equal to minus y cos x plus capital F of y plus g of x. So this is the final solution. So what is the steps? Here first we integrate with respect to x, then we get dou z by dou y equal to minus cos x plus f of y. Here we add an arbitrary function which is in the variable which we kept as a constant, that is f of y. I add f of y here, this becomes equation number 2. Now integrating again with respect to y, this equation number 2. So we get z equal to minus integral cos x dy plus integral f of y dy. Here cos x is a constant, integral dy is y, so we get minus y cos x, and integral fy dy I write as capital F of y, and constant of integration, that is arbitrary function in x, gx. So is it equal to minus y cos x plus f of y plus g of x. Okay.